blood. Like, we all know that it's this red fluid circulating throughout our blood vessels, but what gives it its red color? We know that it keeps us alive, but why? What is in this fluid that is so important? And where does it come from? Like, how does your body actually make blood? Well, today we're going to answer all these questions and even talk about a few conditions when you don't have enough blood or red blood cells. And of course, I won't be able to help myself because we'll also spend some time applying how your blood relates to fitness and athletic performance, and how it can change. It's going to be a bloody one, so let's do this. So let's start by talking about what blood is and some of its amazing main functions, and then we can get into how blood is made. Blood is actually a liquid connective tissue because, like other connective tissues, blood is composed of cells suspended in an extracellular matrix. It just so happens that the extracellular matrix of blood is a liquid that we call plasma. Blood is closely related to other body fluids, such as lymphatic fluid, cerebral spinal fluid that surrounds the brain, and the fluid between the body's cells called interstitial fluid. And this makes sense because these other fluids are actually derived or created from the blood, and replenished by the blood and even returned to the blood. So in a way, you can think of it as that all the fluid in your body at some point came from your blood, which is very important because these other fluids, like the lymphatic fluid, cerebral spinal fluid, and the interstitial fluid, nourish, protect, and exchange materials with every cell in the human body. So in a way, these are some of the indirect functions of blood. But what are some of the more direct functions of blood? Blood is involved in quite a bit of transportation. It transports oxygen from the lungs to the body cells, and then carries carbon dioxide from those cells back to the lungs for exhalation or breathing out. It carries nutrients from the gastrointestinal tract to the body cells, and even delivers hormones from endocrine glands to various targets throughout the body. Blood also transports waste products to the lungs, kidneys, and skin for elimination. Blood is essentially this transport medium for the most incredible and efficient irrigation system on planet Earth, which we would call our cardiovascular system. But blood is also involved in regulation. It helps maintain homeostasis in body fluids, regulates pH through buffering, and is greatly involved in thermoregulation. Like, think about when you're sweating. If you were to work out in a hot and humid environment, that sweat will cool you down. But you are losing fluid in the form of that sweat. And if you were to check someone's overall blood volume after a great amount or after a lot of sweating, and that person did not replenish the fluids lost by drinking, their blood volume would be lower because that fluid to produce the sweat had to come from somewhere. The osmotic pressure of blood also influences the water content of your cells, mainly through interactions of dissolved ions such as electrolytes and plasma proteins, which we'll get into in just a second. And not to get too nerdy and technical about osmosis, but it is really important that you have the right amount and concentration of water in your cells versus the blood vessels versus the spaces between your cells and blood vessels. You have to have balance between all three of those compartments or you can run into problems. Blood also protects you. It can clot to prevent excessive loss of blood after a cut or some sort of trauma, and white blood cells and blood proteins protect against disease through phagocytosis, which is engulfing foreign invaders, and through the production and use of antibodies and other plasma proteins, which we're going to learn about in just a minute. So clearly, there are many vital functions of blood. But what are some of the physical characteristics of blood? Blood is denser and more viscous than water, flowing more slowly through the body. It has a temperature of about 38 degrees Celsius or about 100.4 degrees Fahrenheit. And it has a slightly alkaline or basic pH of 7.35 to 7.45. And this pH needs to be tightly regulated because deviations of this can be quite serious. Like if someone's blood pH went to 6.8, that would likely result in death. Blood color also varies. It's bright red when oxygenated and dark red to a purplish color when deoxygenated. Blood makes up about 8% of the total body weight, with volumes of about 5.6 liters in adult males and 4.5 liters in adult females. And here's a really cool FYI with exercise. With consistent cardiovascular exercise, your blood volume will increase. And initially, this is an increase in the plasma, the fluid component of the blood. And this can actually occur within a couple of days of moderate to intense cardiovascular exercise. But then, over the next few weeks, if someone continues that exercise, the body will also start to produce more red blood cells, which we'll get into more of the details on plasma and red blood cells in just a minute. But both of those changes, having more plasma and red blood cells, will improve fitness and athletic performance. Now, one thing I do want to mention that may seem a little random at first is that your blood and cardiovascular system can actually be affected by your oral health. Like, for example, have you ever heard that tooth decay can lead to heart disease and ever wondered why that is? Well, in some rare cases, bacteria from the mouth can get into the bloodstream and cause a heart infection called endocarditis. But even though that specific infection is relatively rare, there's a tremendous amount of research linking gum disease to other cardiovascular conditions and even diabetes. So we're going to try to help avoid these unnecessary conditions by saying thank you to the sponsor of today's video, Lifen, and their revolutionary Wave electric toothbrush. The Lifen Wave features a 60-degree oscillation and vibration, mimicking the dentist-recommended bass brushing technique. This up and down motion allows the bristles to reach between teeth in previously unreachable areas, which gives you a deeper cleaning experience and removes plaque more effectively than traditional side-to-side brushing that can damage gums over time. The Wave's 0.02 millimeter soft tapered bristles are gentle yet powerful, providing a superior cleaning while protecting your gums. Something that is also very important with oral hygiene is regularly changing your brush heads, as they can wear out and start to accumulate a buildup of bacteria. Lifen offers affordable brush head replacements, with 3 packs for only $9.99 and 6 packs for just $16.99. So with Lifen, you can maintain your oral hygiene without breaking the bank. I have been loving my Lifen toothbrush, and so I don't think you'll regret purchasing one for yourself. So if you're interested, check out the link in the description to learn more and upgrade your brushing routine with the Lifen Wave. So now, let's make some blood, or talk about how your body makes the blood. As I've already alluded to, blood consists of 2 main components: the fluid component, or the blood plasma, and the formed elements, or the cells. So in order to make blood, we need to make both of these ingredients. So let's start with the plasma. Plasma is a straw-colored liquid that makes up about 55% of the total blood volume. And of that 55% of the plasma, 91.5% of the plasma is made up of water, 7% is made up of proteins, and 1.5% is made up of solutes. So to make the water component of plasma, it's pretty straightforward. We just drink water in order to make more and replenish our plasma. But making the plasma proteins requires a little bit more than just drinking water. Yes, you need to have amino acids in your diet that come from eating protein, but once digested and absorbed, the liver will take those amino acids and build the majority of these essential plasma proteins, with white blood cells producing some others. But let me name a few of these plasma proteins, which will just help to solidify some of the functions of the blood that we've previously talked about. Albumin makes up the majority of the plasma proteins. It transports certain hormones, fatty acids, and even certain drugs throughout the blood. It also contributes to the blood viscosity and influences fluid distribution throughout the body. Globulins are another set of plasma proteins that help to attack viruses and bacteria. Some of them can also transport iron, lipids, and fat-soluble vitamins. Fibrinogen is the last plasma protein I'll mention, and this plays an essential role in blood clotting. Now remember, we also said that 1.5% of the plasma was made up of solutes, essentially substances that are dissolved in the blood. And as you'll see, we would get some of these from our diet, breathing, and just byproducts of metabolism. And this 1.5% includes electrolytes such as sodium, potassium, magnesium, calcium, and chloride. It also includes nutrients such as glucose, amino acids, and fatty acids. It includes gases such as carbon dioxide and oxygen, as well as includes various hormones, vitamins, and waste products. So you can see there's a lot to the plasma, and hopefully this illustrates why it's so important for multiple physiological processes that occur throughout the body, and why plasma donations can be so important for certain patients. Like if someone had a certain clotting condition, or they weren't able to produce certain globulins or albumin, getting a plasma donation would greatly help them. And on to the next component of the blood, the formed elements, or the cellular component. This makes up the remaining 45% of your total blood and is broken down into 3 cell types: red blood cells, also known as erythrocytes, white blood cells, also known as leukocytes, and platelets, which are also known as thrombocytes. All 3 of these cell types are actually made by the red bone marrow that is suspended within the deep part of your bones called spongy bone. And this process of producing blood cells is referred to hematopoiesis. The red blood cells are by far the most numerous, so we'll spend a little bit more time on them. And since we've talked a lot about numbers today, let me give you some other staggering numbers. Your body produces over 2 to 3 million red blood cells per second, which means that around 200 billion red blood cells can be produced in a day. That is crazy to think about, but that is just matching the amount of red blood cells that we go through or that are destroyed in a day. So good job to the red bone marrow for keeping up with that. But many of you may have already known that the whole job of the red blood cell is to carry oxygen to the tissues and cells throughout the body. Everything about this cell is designed to make it an efficient oxygen carrier. The plasma membrane of red blood cells is both strong and flexible, which allows the cells to deform without rupturing as they squeeze through narrow blood capillaries. Red blood cells are also one of the few cells that don't have a nucleus, so all their internal space is available for oxygen. And they also lack mitochondria and generate ATP anaerobically through glycolysis, so they don't use up any of that oxygen that they're transporting. Even the shape of a red blood cell facilitates its function. A bioconcave disc has a greater surface area for its volume than a sphere or a cube. So this greater surface area allows for more efficient diffusion of gas molecules into and out of the red blood cell. And if you still aren't impressed by your red blood cells, let's mention hemoglobin. Hemoglobin is an oxygen-carrying protein, which is a pigment that gives blood its red color. Every red blood cell contains about 280 million molecules of hemoglobin, and each hemoglobin molecule can carry up to 4 oxygen molecules. So that means each red blood cell could carry over 1 billion oxygen molecules. And so you can probably see why red blood cells are so important for health and even fitness. We mentioned earlier that adaptation of when you exercise, your body will increase the blood plasma, but also eventually increase the number of red blood cells. If you have more red blood cells, you can carry more oxygen to the exercising muscles. Those exercising muscles can utilize that oxygen in the mitochondria, and you can produce more of the energy currency of our cells, ATP, which equals increased athletic performance and fitness. And a little spoiler alert, we are working on a video about what training at elevation can do for your red blood cell count, so stay tuned for that. But you may have also heard of something called anemia. There are different types of anemia, but in general, each of them is characterized by a reduced number of red blood cells or decreased amount of hemoglobin, which would decrease the overall oxygen carrying capacity of your blood. Some of the common types of anemia that you've probably heard about are iron deficiency anemia. If you don't have enough iron, you can't make hemoglobin. Anemia can also be caused by inadequate intake of vitamin B12 or folate, both of which are needed to make red blood cells. And females are more at risk for something called hemorrhagic anemia due to menstrual bleeding, especially if they are more prone to heavier periods. And after talking about all that cool information with red blood cells, we can't forget about the white blood cells and the platelets. White blood cells protect the body against infections and foreign invaders. There are several different types of white blood cells, each with specific functions. Some get more involved with bacterial infections, while others are more involved in viral infections. Some of them you can thank for getting overly involved with allergies or allergic reactions. Some engulf pathogens, some produce antibodies, and some even keep a record of previous infections so that you can mount a quicker and more robust immune response if you were to be exposed to that pathogen again. So there can be quite a bit of complexity with all the different white blood cell types, so we'll save going any deeper into white blood cells for a later video and finish up with those wonderful little platelets. Platelets are cell fragments that play an important role in blood clotting and wound repair. A blood clot is a gel-like mass that consists of a tough thread-like protein substance called fibrin, as well as platelets and any blood cells trapped in the fibrin. This blood clot not only provides a seal that prevents further blood loss from a damaged area of a blood vessel, but it also pulls the edges of the blood vessel back together to help repair that damage. Platelets come together to form a platelet plug that fills the gap in the blood vessel wall, and this will essentially help to stop you from losing more blood, which from everything we've learned about blood today, that's kind of important. So hopefully today's video provided you with some new and useful information about blood and possibly a new toothbrush. So be sure to check the link in the comments for more information. And while you're in the comments, feel free to leave us one on what you thought about today's video. And I'll see you soon.